Hello everyone. So today we are going to solve third maximum number. So it says that given an integer array nums, return the third distinct maximum number in this array. So that means we can have duplicates as well. If the third maximum does not exist, return the maximum number. Okay, so basically we are given a nums and it may not be sorted. What we are supposed to do is give the third distinct maximum number. Okay, I mean, one very basic way I can think of is we can have three pointers or three numbers which will keep track of the three maximum numbers, right? And once we have that, actually we'll need to sort it. So once we sort it, uh, the third maximum number is what we'll return. So we can have three pointers, or even if we don't sort it, we can kind of do it, without sorting. But the issue here I feel is that if I go with that way, there can be a follow-up which will say, let's say I want now the fifth maximum number, right? So then we'll need five pointers to keep track of that. So that's kind of weird way to do it. So what I can think of here is I want it to be sorted, maximum number, and then once they tell us, give me the xth maximum number, I can just return it. So we can make use of priority queue here. So what I'll have is a priority queue. And what this priority queue will have is integers. And yes, and how the numbers would be sorted would be, let's sort it by max to min, okay? And then what we'll do is we'll return the third maximum number if the size is equal to 3. And yes, so my priority queue would be, let's take a bigger example. I feel this is too small. So let's take 2231, 2231. So for this, I'll have a priority queue which will have 2. Then I'll add, now if there's another 2, I don't want to add it in the priority queue again. So I'll need some data structure should keep track of this. So that would be a hash set. So that hash set will make sure that I don't put duplicates in my priority queue. Then, so this 2 will be ignored. Then I get a 3. So 3 comma 2, and then I get a 1. So I'll put 1. Okay. Let's say I get another number 4 here. Okay, so if this was the array, I just need to return 1. That would have been my maximum value. If I didn't have 1, it was just this, I would have to return the max between these two, which would always be the first element of my PQ. And if I had 1 comma 4, right, then this would be 4, 3, 2, 1. Now I need to return the third distinct number, right? So I'll go over priority queue and return the max of these. Or actually, let's keep only the 3 max values in the PQ. So when I get the fourth element, right, this is the status of my PQ and I'm putting 4. What I'll do is I'll remove the minimum element from here because I want to return the maximum. So I'll remove 1 and I put in 4. Yes, now the issue here is that if I do this, I can't remove the last value from the PQ directly. I'll have to go over it. So what we can do is, instead of storing max to min, let's do it min to max. So it would be something like initially I get 2, then I get another 2, hash set will kind of not take it. Then I'll get 3, so this will be 2 comma 3. Then I get 1, so 1 comma 2 comma 3. And then I get 4, right? Now I see that this is already 3, so I'll have to remove 1. So I'll remove the minimum, which would be pq.remove, and then I'll add 2 comma 3 comma 4. And if it's 3, I can just return the first element. If it's not, I'll go over and return this. Yes. So this makes sense. So I'll have a hash set is equal to new hash set. And the idea here is that I'll go over all my nums, right? And I'll check if my hash set contains this number, right? And if it contains, I'm just going to continue because I don't want to put duplicates in my PQ, right? And if it does not, I'm going to add it to my hash set so that it's there. I know this value will now be there. And my PQ is ascending order, so that's fine. What I'm going to do is I'm going to check if my PQ.size is equal to 3. So it's 3 because they have asked me for the third maximum number. If they, let's say, asked me to change it to 5, I would have put it at 5 here. So at any given point, my PQ will have only 3 numbers. And if it is less than that, right, I'm just gonna add my number to the PQ. Now let's say if my PQ size is 3, right, and I get a new number, what I'm gonna do is I need to check if this new number, so I could, let's say I get a 1 here now, right? So I don't want to put 1. So this was the case, right? So 2, 3, 4 is there, and then I get a 1. I won't put 1 in my priority queue because it is lesser than the first element of PQ. So I want to check if my PQ dot peak, if it is less than num, then only I'll do a PQ dot poll and PQ dot add num. If it is not, I'm not going to do anything, right? So at the end of this, I'll have a PQ. And what I need to do is I just need to check if my PQ dot size is equal to 3, right? If it is, then I'm gonna return PQ dot poll. That is the first element, right? Else, if my size is not like that, right? So what I need to do is return the max of all the elements of this. Else, int max is equal to PQ dot poll while my PQ dot is empty. While it is not empty, my max will be okay. So the reason I'm doing this here is because even though I know that my last value is the max, I have to iterate because this could be in turn like this, right? And now in this case, well, actually this is never going to be like this. So if my PQ size is not 3, it's going to be either 2 or 1, right? So I'm going to do this, and if my PQ dot not is empty, then I'm going to do max is PQ dot poll, right? And then I'm going to return max. So this should solve the problem. What I'm trying to think is, let's say if they say that give me the fifth max number, so this will change to 5, right? And my PQ will be of size 5, right? And now, so yeah, I can't have a while, I need to have a while loop here. So that way, in that case, I'll get over to the end of the value and return it. Okay, this looks good. Okay, what did I miss? Else this. Yeah, okay. Let's remove these. Run. Okay, this looks good. Let's try to submit. Awesome. So I was able to solve this. What I can think of one more thing is that, so basically how this is working is this, it's taking a PQ which will keep the number of elements which is being asked. So this 3 maximum numbers. Third maximum number is what we have to return. So the size is 3. And that is the size of my PQ. And this HashSet is basically making sure that PQ doesn't have duplicate elements. So this PQ is going to have the 3 maximum numbers after we go over this whole nubs. So after we go over all of these, my PQ will have 3 maximum numbers. And if I have 3 numbers, then I'll return the first value there is, since it's in ascending order. If there is less than that, then I return the maximum value, which will be the last element of PQ. In terms of time complexity, this would be O of, I'm going over all the nums once, and PQ. Okay, so this is O of n because since PQ is not really sorting more than 3 elements at a time. So if this would have contained all the elements, it would have been log n and log n, but that's not the case. So it will be just O of n. Since I'm going over the num series just once, and the sorting for PQ would be in a constant time for 3, so 3 log 3 basically, and my space would be O of, so this is constant space because I'm not putting more than 3 elements. HashSet can be at max O of n, so space could be O of n here. So this is the time and space complexity of this solution. So this is one way to solve it. What I'm trying to think is, since can I get the space down to O of 1? And I feel like since I'm using PQ and a hash set, right? That's basically a tree set in Java, because what's going to happen is PQ is just doing the sorting part and hash set is making sure I don't have duplicate. So rather I could have a tree set, right? And this will basically keep track of all the numbers. And I'll go with this and I'll check if my tree set contains this. I'm going to continue, else I'm going to add TreeSet.add, right? And oh, actually, I don't need this now, because what I'm going to do is I'm going to check if my TreeSet.size is 3. If it is not, I'm just going to do TreeSet.add now. And if TreeSet.size is 3, then what I'm going to do is basically, it's an ascending order. I will remove the first value, so TreeSet.poll first, and then I'm going to do TreeSet.add now, right? So at any given point, I'll have just 3 values, right? And at the end of it, what I'm going to do is, so this is the best part actually, I think, because I don't need to do any of this, because my tree set at the end will have just 3 values sorted from 1 to 3, right? And I want to return the maximum value, right? So I just need to return TreeSet.poll last. The reason for this is because, let's say if I have, because at max I'll have 3 numbers, right? So if I have 1, 2, 3, so in this case I just want to return 3. But if I had 2 elements as well, and my tree set guarantees that my last element will be the max number, I just return the last one. So I feel like this way, my time complexity is still O of n, because I'm going over all the nums, right? And my tree set is just sorting 3 elements, so it's constant time. And I don't need a space anymore, because this tree set will at max have 3 elements itself, so space will become O of n, O of 1. So yes, I think this is a better solution than that. Let's see if this works. Okay. So for 3, 2, 1, my output is 3. Oh, I see. Okay. So here, so I think I did one mistake. So if TreeSet.size is 3, I'm actually returning the first element. So I'm returning TreeSet.poll first, right? Because the third maximum, else I'm returning last number. Okay. Yeah, this looks good. Okay, your output was 0, expected 4. Why? So what happened here was I had 5, I had 2, I had 4. I got 1. So if preset size was 3, I'm gonna pull the first one, which is 2. Oh, and then my tree set dot first, it is less than the current num. Actually, this is wrong, because because what this will do is, if either of these is false, it's gonna add it in my tree set. I don't want it. So I only want this to happen if my tree set dot first is less than num. So yes, this looks good. Awesome, let's submit. And there we go. Awesome. So we saw 2 approaches. Basically, we started with a priority queue and a hash set to make sure that we don't have duplicates in PQ. So, but that was O of n space extra, because we had a hash set, and then we moved to a tree set, because that's basically PQ but a set. So that way we don't have to use extra space. That's it. Thank you.